All right, good day, everybody. Good day, students. If you are hearing the sound of my voice and you are seeing my slide, that means you can see the screen, Thermodynamics I, MCH 201. Can you type 11 on the chat box? Okay, David Nemeka, you already know I would say this and you already started typing 11. All right, that's good. All right, that means I can be heard. That means I can be seen. Now, another thing for you to do, I want you to send the name, your study center number, your real name and your study center number. Send it on this platform. I want to know where you are joining from, where your study center is. So David Nemeka, Muyin Olarewaju, Chidebere Martins, Chikeze, write your full name and your study center. Send it on this platform right now. Attendance will be taken. Please do it in one write-up. Do not write and give space, and another person will write and it will mess it up. Write it in one write-up, your real name and your study center. Let's do that while others are coming in. Adebiyi, Okiki Jesu, Chidebere Martins, Dada Olalekan, David Nemeka Ude, Muyin Olarewaju, Prosper Osegi, Yomi is okay. Go to the chat box, type your real names and your JPS Study Center name. Quickly do that as I welcome all of us to this course today. Thermodynamics I, MCH 201. Okay, Dada Abdulatif Olaleko of our Study Center, Computer and Software Engineering, Adebiyi Okiki Jesu Victor Ijako Center, David Nemeku De Iyano Ipaja Center, Chidebere Martins Chikeze Ijako, Marawatu Muin Ekpe Center. All right. Still expecting more persons. We are 10 in. I have 10 students here. Marvelous Ajayi, Team Dominic. Which centers are you from? Please do not unmute your mic. Kindly do not unmute your mic. Use the chat box. Do not unmute your mics. Use the chat box, please. All right. If you have been joining our classes, this is about the third class that we have held in this course, Thermodynamics I, MCH 201. My name is Engineer Osita. My name is Engineer Osita, and I am your lecturer for today's course. One of the things I have stated all the while is that, let me set up this. That the following things are what I expect students who are attending these classes should do. Number one, your attendance should be at least 80% attendance. Attendance goes a long way in ensuring that your cumulative for the exam is assured. Number two, when you come into this class, ensure you are muted, your microphone is muted, and you have your physical notepad, physical pen, or electronic notepad, so that there are important things I will be saying. I will now, when I say it, you're expected to take it down, because it's not everything that will be on the lecture materials. Number three, there are research work that you ought to do. And once in a while during the lectures, you would be seeing the research work link that I will be posting that will assist you in your research work. Number four, you are expected to participate in the assignments that will be dropped on these lectures. Sometimes you ensure you can do the assignments, participate in the assignments, and get them submitted. There's an email ID that will be dropped towards the end of this course today, that you will be sending your assignments. I'm aware I have dropped about 3 assignments in the preceding weeks. So all of you that have been attending these classes and those who are opportune to attend today, I'll be sending you the links. Ensure you drop your assignments on those links on or before the stipulated date. They would also go a long way in your cumulative for the exams. Number 5, I think is number 5. You would be getting this lecture material majorly for those who attend my classes. I'm not going to be selling any material. You're not going to be purchasing any material. It's not for sale. I'm doing it free of charge to ensure that you get as much material as possible to help you not only in your education, but to help you in your career as future engineers. My name again is Engineer Osita Arukwe, and I wish you good luck as we continue with this course. Once again, I expect as you join, you have muted your mic and you are indicating on the chat box your name, your department, and your center number. Okay, no problem. Just indicate, tell me something about about yourself, your name, your center, your study center. Okay, if you want to add your registration number, no problems. Just ensure that you are giving me that information that we would use to know your attendance. Ajayi Marvelous from Ujodu Agege. All right. Dadab Abdulatif of our study center. Okay. Anybody from Lekki, anybody from Abaranje, anybody from Ijako? Okay, there's a Kundayo, okay, Ijako. Yes, I'm seeing, let me check. Okay. Anybody from Ikorodu here? I've not seen any Ikorodu center. I've not seen Abaranje. All right, so we go ahead. Let me recall what Let me recall.
Engineer Sita, good afternoon or good morning.
Yes, sir.
Yes, okay. Please quickly, I would interrupt this class a little because I would like to give a more directive on how the online classes should go, because I can see that many of the engineering students are not taking these online classes serious. My name is Professor Chris. And the reason why we set up this online class is because many of you complained that you are not having your core courses taken. Now, the head office has taken it as a responsibility to set up a special online class, live class, not even recorded, for engineering students, so that you guys can have access to your core course. Look at the course like thermodynamics being taught, and you only have 11, 19 persons in class. A class that's supposed to have over 500 students. Is it that you guys are not informing your other colleagues about these classes? Why are they not taking it serious? Please, lecturers for online classes must take attendance very serious. And I also want to say that there must be tests at the end of every classes. How should you conduct the test? Read out the test. Read out the question. Engineer Sita, Engineer Ma, and Engineer Nathaniel. Read out the question. At the end of your class, you can give 2 10-minute test questions. So all students tear sheet of paper wherever you are. Then you read out the question. Question number 1, what is the fundamentals of thermodynamics? For example, give us 5 fundamentals of thermodynamics. You give 5 minutes for that. Question number 2, you give 2 questions. They answer the question on their sheet of paper. At the end of the 10 minutes, they snap it and they upload it to your link. Those that will not upload it immediately after 10 minutes misses the test. And lecturers are mandated to mark that test question, then you upload it on the WhatsApp group. Let people start knowing that this online class is very serious. We're taking it serious. Nigerians must begin to see online as an option for learning. That does not stop your physical class, but this online class, as related to engineering students, healthcare students, is a very serious one, and students must take it serious. If students don't attend online classes, they will fail, they will not pass, they will not graduate. That is just the fact. Because if you say we should start sending lecturers to your center, some of you have only 2 students studying electrical engineering. How do we do that? Now we have been able to call all of you to galvanize into one and take your courses, your exams, your classes online. You now add it to whatever you are doing physically. Believe me, you enjoy it. Very soon, we're also planning to making sure that some of our, especially in Lagos, we start having our practical. We are equipping one of our school with practical workshops so that weekends students can come around to do their practicals. So if management set up a platform for you, it is important that students take advantage. So those of you who are online now, you are now 22, must make sure you contact all your classes. As Engineer Sita, you must have class reps for every center, every student. So all these people that are here now, they should be appointed as class rep. It becomes their duty to ensure that every student in your class attend these lectures. So the 30 marks that go for continuous assessment will be graded from the online class. Let's take our online classes serious so that we can get the knowledge we need to get and become a better student. That is our wish for our students. It's not easy to run a multi-systems campuses that we are running. We are trying to see how we can balance quality with making sure that we have multiple centers. And we cannot achieve that if students are not helping us to get that achieved. Thank you.
Thank you very much.
Yeah.
Thank you very much, Prof. Okay, we have had it. Everyone on this platform, you have had it. That was the voice of the Vice Chancellor of JPTS himself, Professor Christopher Imumole. He has been here and he has given a charging order. Go tell it on the mountain. Go tell it everywhere. Go to your students, to your colleagues, to even the coordinators that the Vice Chancellor came on this platform today, Thermodynamics I, MCH 200201, and gave a marching order. Online classes are as important as your physical classes. They are the same thing, and it must be carried out. You must attend online classes, and there is a cumulative mark that goes for this, and you have heard it. Now, by virtue of this charging, 2 things have come out of it. Number 1, assignments, which if you have been attending this class, you will notice or you will be aware that their assignments are embedded in this course. So assignments will be done here immediately after each lesson. 10 minutes will be given for those assignments to be done by those that are in the class, and you will submit the assignment to the link that I would post, and it will be marked and the results will be shown and dropped on the WhatsApp and the Telegram links. Also, you will be, all the members who are, all the students who are here representing each study center, you are automatically the course reps, the online course reps of your center. So I'm taking down the notice of everyone. As you come in, write your name, your registration number, your student study center. That means it must be your real name that must be there. It will not be proper for you to be writing the name Infinix Note 2 or Zoom name. Insert your real name and you are automatically the study center, online study center course rep. I'll be reading out the names at the end of this course. All right, if you have understood what the Vice Chancellor said and my recap, can you go to the chat box and type 11? Go to the chat box and type 11. Okay. All right, good. So we continue. So having understood that, my name once again is Engineer Sita Arukwe, and I will be your lecturer for today's course, Thermodynamics I. All right, like I said earlier, some of the lessons we are going to take now, we have taken them previously. I'm going to run through them. I will be sending these materials, lecture materials, basically for those who are attending today's lecture. And you will have your assignments today. We'll do the first assignment today, and it will be submitted immediately. So get your pen and paper ready. Get your pen and paper, physical pen and paper, or get your electronics notepad. You will do it and you will upload it immediately to the link that I'll be posting on the chat box. It will be marked. It will be marked and it will be sent. The results will be sent on the WhatsApp, and the Telegram. Okay. While you are digesting that, give me 1 second to fine tune my mic. All right, I'm back and we continue. Um, we started first by putting a definition to what thermodynamics was all about, and it's concerned with the ideas of heat and temperature, as well as the exchange of heat and other forms of energy. We understood that the branch of science of thermodynamics is related to the study of various kinds of energy and its interconversion. Energy, heat, it can be converted from one state to the other, but generally they are always zero. The behavior of these quantities is governed by three main laws, which we will be looking at later, and it provides a quantitative description. Actually, the word thermodynamics was coined by William Thomson in 1749. Furthermore, thermodynamics as a field of science investigates the links between heat, work, and temperature. We're going to be looking at those terms, concepts later, as well as their interactions with energy, radiation, and the physical properties of matter. Okay, sorry about that interference. So thermodynamics in its broadest sense is associated with the transfer of energy from one location to another and from one form to another. Heat, let us look at heat, sorry. Heat is a type of energy that corresponds to a specific quantity of mechanical work, which is a key concept in heat. It discusses how thermal energy is transformed to or from other forms of energy, as well as how this process affects matter. The energy that is derived from heat is actually called thermal energy. We are already aware from our junior science class, let me take us down memory lane, that all objects are made up of particles and molecules, and these molecules are always in vibration. That you don't see does not mean they don't vibrate. Now, because they are tightly packed, the type of their packing determines what kind of structural states they are. The solid states are, the molecules are so tightly packed that they rarely vibrate. The molecules are so tightly packed that the areas of their vibration is very small. But at the point of heat exchange, or at the point where heat is, the thermal energy increases in it by increase of heat, the bonds that are holding these solids begin to break and the molecules begin to vibrate faster. And as they vibrate, the molecules themselves begin to separate from the bonds that are holding them. The space that is in between them increases, and the molecule and the substance itself that is solid converts to liquids. With constant heating, it changes to gases, and that is what you get, the different states of matter. Now, all this is possible by the thermal energy that penetrates the object ab initio. Next slide. Let us look at the basic concepts of thermodynamics. We looked at system, where a system, we said, refers to a specific part of the universe that is being observed. The universe is infinite, so we cannot at every point in time begin to look at the entire universe. We have to look at a part of the universe. We have to look at a part of the universe, and that part that is involved with what we want to talk about is the system. Therefore, a thermodynamic system is a part of matter with a defined boundary on which we concentrate our attention. The system boundary can be real or imaginary, and it can be fixed or movable. Physical qualities and chemical compositions are said to be homogeneous if they are consistent throughout the system. The system, on the other hand, is considered to be heterogeneous if it is made up of parts with varied physical and chemical properties. Now, here I've introduced what is called a homogeneous system and a heterogeneous system. A homogeneous system is one in which the chemical compositions are consistent throughout the system, while heterogeneous is actually when the chemical compositions are not consistent. Now, depending on how matter and energy travel in and out of a system, it can be divided into three categories. These are the three types of systems. Let us look at the three categories. We have the open system, we have the closed system, and we have the isolated system. Now, the open system or control volume is one that can exchange matter as well as energy with its surroundings. As a result, mass and energy can be transmitted between the system and its surroundings in an open system. Now, since it gains and loses matter as well as energy, this happens. And an example is hot coffee in an open flask. It's an example of an open system. An open system is also steam turbine. These are all examples of an open system. So one point to note is that in an open system, which is also called a control volume, it's a system that can exchange matter as well as energy. In a closed system, the system exchanges energy but does not exchange matter. That means there is no mass movement. There's no increase or reduction in mass, but there's increase or reduction in energy. Now, the transmission of energy takes place across the closed system's boundary, but the transfer of mass does not, which we have said. An example of a closed system is your refrigerator, your gas compression in piston cylinder assemblies. You know your refrigerator, the principle is that whatever mass you put in, the mass remains the same, but there's a transfer of heat. There's a heat exchange. But in an isolated system, it is one that is there is neither an exchange of matter nor an exchange of energy with its surrounding. In reality, there's no actual isolated system in reality. So we can say that in an isolated system is one that is entirely sealed to prevent matter intake or outflow and is thermally insulated to prevent heat flow. Now, if you are logged out by the system, just relog in and we will continue from where the system stopped us. For those of us who are just coming in, I have said earlier, we had in the class the Vice Chancellor of JPTS in the person of Professor Christopher Inomole, and he has given us charging orders. As you come in, ensure you mute your mic, ensure that you join in with your real registered JPTS student name. Go to the chat box, tell me your name and your study center from where you are joining in from. At the end of today's lesson, we will be having our assignment, which will be live. You will do the assignment either handwritten or electronically, and you will upload it on All right, so what you will do is that, well, you're going to handwrite it. You are going to handwrite it, write it on a piece of paper. Ensure you are the one that is doing it. You are not copying and pasting from anywhere. Ensure you write it with your hands, screenshot, snap it on your phone and upload it to the Google link that I will be posting at the end of this lecture. Again, assignments will be given at the end of this class. And those of you who are attending this class, which you know that your attendance is very key and it goes to your cumulative, you are going to do the assignments immediately, write it on a paper and upload it to the link that will be given after this class. All right. Let me check. All right. So we are online and we are good to go. So that is what a system, that's what isolated system is. Now, on your surroundings, the remaining portion of the universe that is not part of the system is known as the surrounding. Every system is bounded by a surrounding. Actually, it's bounded by a boundary that separates the surrounding from the system. So the term surrounding refers to everything outside the system that has a direct impact on the system's behavior. In other words, anything outside of the system is included in the surroundings. Together, the system and the surroundings make up what is called the universe. Now, the alterations in the system, on the other hand, have no effect on the entire universe, of course, because if we are looking at a system, it is only in that system that whatever we are conducting, what experiment or whatever we are doing is being affected. As a result, the surroundings are that portion of the remaining universe that can interact with the system for all practical purposes. In general, the surroundings are defined as an area of space in its surroundings. Now, apart from surrounding, another concept or term that we ought to know is the boundary. I mentioned it earlier. The boundary could be real, it could be imaginary. It's a surface that separates the system from its surroundings. The boundaries of a system can be fixed or movable. Mathematically, the boundary has zero thickness, has no mass, and has no volume. Right? Remember, if you are logged off, you just relog in and we continue. Let's look at the concept of work and energy. Energy actually does not, or rather, when we talk about energy, it could be a bit elusive. I had mentioned earlier that even in this slide that when someone is pushing a car, we would say that he may be doing work, because actually the word is derived from the Greek word ergon, meaning work. But the term work itself acquired a technical meaning with the advent of the Newtonian mechanics. You remember the Newtonian laws, the first law, the second law, the third law. Particularly the first law, every object continues in a state of motion or stationary, except it is acted upon by a force. Now, it means that an object that is stationary needs a force to act on it for it to move, or an object that is already moving needs a force to act on it for it to stop. So for example, if you are pushing a car, a man that is pushing a car feels that at the end of the day, he has done some work because he will be sweating. But actually, if that car does not move, no work is done. So actual work is done when that car actually moves. So work done is then the product of force applied by the man multiplied by the distance through which the car moves. So of course, two factors are involved here. If the force is higher, the movement of the car will be farther. Again, if the distance with which the man pushes the car is longer, then of course the distance will be farther. Let us look at the next slide. These are some of the things we touched on during our previous classes. We looked at temperature. The concept of temperature is fundamental to any discussion on thermodynamics, but its precise definition is not actually a simple matter. Actually, one would say that the temperature is how hot or how cold an object is. Actually, a steel rod feels colder than a wooden rod, but again, it depends on the environment with which that particular material is felt. It is therefore necessary to have an objective way of measuring temperature. In general, when two objects are brought into thermal contact, heat will naturally flow between them, actually from the hotter region to the colder region, until a stability occurs, and that stability is called equilibrium. When the flow of heat stops, they are said to be at the same temperature. Okay. Keep your names coming in and your center. Keep your name coming in and your center. Oluwasegun Joseph, write your center, indicates your center. All right, let us look at thermodynamic equilibrium, because we've talked about stability of two objects that are in thermal contact. Let us look at thermodynamic equilibrium. All properties of a system have fixed values at any given state. As a result, even if the value of one property changes, the system's state changes. While a system is in equilibrium, the value of its properties does not change when it is isolated from its surroundings. So, basis this, let us look at different types of equilibrium, thermal equilibrium or thermodynamic equilibrium that we have. We have thermal equilibrium, we have mechanical equilibrium. Remember, we're talking about thermodynamic equilibrium. We have thermal equilibrium, mechanical equilibrium, chemical equilibrium, and phase equilibrium. In a thermal equilibrium, a system, this occurs when the temperature is same throughout the entire system. Throughout the entire system, the temperature is same. We have what is called a thermal equilibrium. In a system, when there is no change in pressure at any point in the system is said to be in mechanical equilibrium. While a system in which the chemical composition does not change over time is said to be in chemical equilibrium. Now, this next one is very important because you'll be seeing this largely in all your classes, right from the 100 levels upwards, the phase equilibrium. When you have more than one phase, for example, you have the solid and liquid phase, which you know it is transient. It changes per time of the same object. Now, in a two-phase system, for example, a liquid and a gas, a solid and a liquid, at a point, there is a point that each of these phases reaches an equilibrium. There's a phase of the solid, there's a phase of the liquid. There is a point where there's a stability of these two phases. This is called a phase equilibrium. All right. Let us look at the next